Hello, everyone. So this is what I'd like to talk about, algal bloom sensing. My name is Anu Agarwal, and as Leon pointed out, we have a joint collaborative project between Masdar Institute and MIT. And one of my students is here today, Jia Hong Han. You'll see him around. First, I'd like to tell you about why we should care about algal bloom sensing. Why do we care? Well, I'll tell you. Also, I'd like to tell you a little bit about the market for the water industry, water quality monitoring. And our device, our algal sensing device, is not just a product, but we envision that it can become a platform in the future. I'd also like to tell you about what exists today in terms of algae sensing and what our solution is to the current problems. And finally, I'd like to go further in the future and talk about a general purpose programmable chip. So why should we care? Well, first of all, algae are toxic pollutants, and they harm humans as well as fish. Also, they have huge implications in terms of financial losses for companies such as desalination plants, water treatment plants, and even fisheries. So we do need to care. Now, having just a few algae, it doesn't really matter. Almost all water bodies have them. What really bothers us is this bloom event. How does an algal bloom actually happen? The algae feed on the nutrients present in the water, and then they bloom. So what we thought about is, why not predict when an algal bloom event actually will happen? As opposed to just saying that there's algae in the water, why don't we predict that it'll happen? And this prediction will allow us to warn city residents of impending danger, also warn water treatment plants to shut down. And our idea is to use an optics-based sensor that can detect both algae and the nutrients that the algae deserve or need in order to grow. So the idea is a very simple one. Why not detect both on the same platform? And this platform actually enables us to do even more, not just water quality monitoring, but we can do even more in terms of chemical sensing in the future. So water quality monitoring globally, first we start with algae and nutrient detection for algae sensing. Then we go further and do water quality monitoring, which is general, and then even further to chemical sensing for all kinds of commercial and military applications. So this is the path that we are trying to forge. Here's a projection for water quality monitoring and smart meters. It's about $7 billion US. And that's nothing to scoff at. Our device enables a platform that goes, as I said, beyond algae sensing and water quality monitoring. It can be used in the healthcare industry, in other industrial settings, and also for homeland security. So it's an enabler of something bigger than just water. What's the current landscape of algae sensors? And how does our solution bring something better? Our sensor is a predictive sensor. So first of all, rather than just tell you that there's algae in the water out there, we'll tell you when a bloom is supposed to occur because we sense both the algae and the nutrients that they need. We're a microsensor. That adds a lot of advantages, as you all probably realize. First of all, high volume manufacturing, low cost, portability, and so forth. And finally, it's not just a product, it's a product and a platform. That's what I'd like to stress. What's our technology? The water we envision will go from the water pipes through a microfluidic channel to our sensing chip. And how does our sensing chip look? Well, it has on the one side algae detection, and on the other side, chemical nutrient detection. So the algae detection side has an ultraviolet LED, which brings light through the waveguides into the body of water that we're sensing, giving us a detection event of algae presence. On the other side, we have a broadband light source that brings light again through waveguides to filters designed for different wavelengths. And when we see both algae and the nutrients present simultaneously, we envision a communications module giving out a signal, warning residents and warning treatment plants that an algal bloom event is imminent. So again, I'd like to just summarize the key benefits of our proposed technology. Predictive, it's a microsensor, so it brings along all the advantages of micro, and it's a product plus a platform. Here's what we've already demonstrated in our labs. It's a waveguide device through which an optical mode propagates. And if there are any chemicals present in the vicinity of this mode, what happens is that optical mode changes. And that change is detected, leading to a chemical sensor. So I talked about making this a general purpose chip. How do we do that? How do we plan to do that? Well, first in year one, we'd like to focus on the algal bloom part of it. And that we'll do with detecting algae and nutrients simultaneously, which can alert plants, save lives and dollars. But in year two, we plan to go further. We plan to build a platform that can enable a network of sensors. One can envision that there's this network of sensors, not just for water quality monitoring, but also for industries like air quality monitoring, industrial monitoring, and other commercial applications, as well as military applications. So there's a whole plethora of opportunities that open up to us when we have this platform. I'd like to invite you to visit our poster, which is down the hall here. Thank you.